Hi there, this is just a quick video to show you how to draw error bars on a graph. So what we can see here is we've got a graph that's been plotted for us already, which has been taken from this data table over here, which is, just to put it into context, is looking at the time taken for starch to be broken down by the enzyme amylase in minutes. And we're looking at the effect of temperature on that. So we've got different temperatures on the left column here, then we have the mean time taken over here, and then we've got the standard deviation, which has been calculated for us already. So what we want to do is to be able to plot the standard deviation error bars on the graph, so that when we look at them visually it's much easier to see what the level of error is around each plot. So if we remind ourselves of what standard deviation is, it's the amount of the range of data around about the mean. So what we're going to look at is the first one here, 4.1, and we're going to look at the standard deviation, also for 10 degrees Celsius, which is 0.8. And the easiest way I find to do it is to, first of all, actually calculate the highest and the lowest values. You're going to be basically plotting 0.8 above the mean here and 0.8 below the mean. So what I would need to do to find the highest value is 4.1 plus 0.8, which gives me 4.9. So I'm going to be going up plus 4.9. And then my lowest value is going to be 4.1 minus 0.8 to go down. So I'm going to be going to 3.3. So let's plot our first one onto our graph. So here's my first plot. The first thing to do is, of course, check what the equidistant values are from between 0 and 1. So each square I know is going to be worth 0.2. And that makes sense, doesn't it? Going 0, 0.2, 0.4, 0.6, 0.8 and 1. So let's go up onto the graph here. We can see that our plot is currently at 4.1, so I now need to go to 4.9, which is going to be, there's 4.2, 4, 6, 8, and 9 is going to be in between those there. And you would use a ruler, of course. I can't use a ruler on here, so make sure you use a ruler and a sharp pencil. And we're going to plot the bottom bar as well, so 3.3. So it is 3.2, there's 0.4, so it's going to be in between and across, nice and neat. So you can see I've gone across two squares there. I'd suggest doing that just to make it really clear to whoever's looking at the graph afterwards, or the examiner. And then again, you would use a ruler and you would then draw down, and please forgive my wobbly lines here. Okay. There we are, and there's our first error bar drawn, or a standard deviation error bar. And as you can see, it's a large error bar, so probably not particularly reliable data in the raw data that we got the mean from. Okay, let's go on to the next one. So same thing again, 4.9 plus 0.5 gives us 5.4 is my highest value. And then I'm going to do the bottom value, 4.9 minus 0.5, that gives me 4.4. So now I'm going to plot, and I'm going to go to my plot here. I need to go to 5.4, so there's 5, 2, 5.2, 5.4, and I'm going to draw, whoops, as neatly as possible. And then we got 4.4 below that, so there's 4, 4.2, 4.4, and hopefully, neatly this time, we go across. And then I'm going to just draw down to my plots. So it looks something like an error bar. Remember, ruler. Okay, next one. Let's go on to the next one. We've got 0.98 plus 0.1 equals 1.08 is going to be my top value. And then I'm going to do 0.98 minus 0.1 equals 0.88. Okay, and so plotting this can be a little bit more difficult because it's we're down to a much smaller number here. So if there's 1.2 there, 1.1 must be in the middle, so it's going to be something a little bit below that. Tricky one to do. with the scale here. And then the next one, we're going to do 0.88. So there's 0.8. And now we're going to go up to almost 9, which would be almost halfway, but not quite. And there we've got a much smaller error bar on this one. And okay, so there we are. Let's go on to the next one. We've got the same standard deviation on this one. So 1.2 plus 0.1 equals 1.3. And then we do 1.2 minus 0.1, which equals 1.1, gives me my bottom value. Okay, and again, so we've got it's at 1.2 already. We need to go to 1.3. There's 1.4, so it's going to be in the middle, approximately. Remember, use your ruler. And the next one is going to be 1.1. So there's 1.2 already where it's plotted, the mean, and then we're going to go in between that and plot, like so. Okay, so we'll keep going. So the next one, our 50 value, we're going to look at 2.1. We've got a standard deviation of 0.2. So 2.1 plus 0.2 gives me 2.3. My top value, and then 2.1 minus 0.2 gives me 1.9. So it tells me exactly where I need to plot. That's useful. So for 50 then, there's our mean. We need to go to 2.3. There's 2.2. 2.3 is going to be in between. There we are. And then our bottom one is 1.9. So there's 1.8. And I'm going to go in the middle. So there we go. There's our next one done. And then we can keep going. 4.6 plus 0.2 equals 4.8 is my top value on this one. 4.6 minus 0.2 equals 4.4. Okay, so we can plot these now. So here's my mean. I need to go to 4.8. So there's 4.8 there. And then my bottom value is 4.4. So there's 2, there's 4. Lovely. There we are. And there's my error bar drawn. We'll keep going. Next one is 70 degrees, 5.3, standard deviation of 0.4. So 5.3 plus 0.4 equals 5.7. And then we've got 5.3 minus 0.4, 4.9. And okay, so let's plot that. So 5.7, so we've got 2, 4, 6, 8, so it's going to be in between. And then we've got 4.9, which is going to be, there's 4.8, so it'll be in between. And then we can draw it in. And then last but not least, we've got 5.4 plus 0.6 equals 6, dead on. And then we've got 5.4 minus 0.6 equals 4.8. And then we can draw it in. So 5.4 up to 6. So there we go, that's an easy one. And then 4.8, again, an easy one, which is here. And we can draw them in. And there we go. That's your error bars drawn in, using the top and lower values, adding in that standard deviation to your mean. I hope that's been helpful. Key tip, remember to use a ruler, and remember to calculate those highest and lowest values. Okay, thanks very much.